We now determine the absolute extrema of the function f of x equals x squared minus 4x minus 6 defined in the closed interval 0, comma 2. So first we determine if there are any critical points in this interval. So we find the critical point of the function by setting up this derivative equals 0, that is the first derivative equals 0, and solving for x. So we find the derivative of f of x by differentiating both sides with respect to x. So we have f prime of x equals the derivative of x squared is 2x when we use the power rule, and the derivative of negative 4x is negative 4 times of the derivative of x is 1, and the derivative of negative 6, which is a constant, is 0. So basically we get f prime of x, and this equals 2x minus 4. Now we have to set up f prime of x equal to 0 and solve for x. So therefore I replace f prime of x equals 0, and this gives 0 equals 2x minus 4. And from this we can solve for x. So 2x equals 4, and x equals 4 by 2, which is 2. So this is the critical point of the function in this interval. And now we have to prepare a table for x as well as f of x, including this critical point as well as the end point. In this case, the critical point happens to be one of the end point. So let's prepare the table. This is x and f of x. We put the endpoints, that is 0 and 2, and the critical point is also 2, so we put two values for x, that is 0 and 2. Now we have to determine the function values when x equal to 0 and when x equal to 2. We can determine this by plugging in x equal to 0 into f of x, and when we do that we get f of 0, and this equals 0 squared minus 4 times of 0 minus 6. So this is 0 and this is 0, and here we have negative 6. So f of 0 equals negative 6. So I write negative 6 for x equal to 0. Now we find f of x when x equal to 2. So let's plug it into the f of x. So I write f of negative 2, and this equals, I'm sorry, we have to plug in x equal to 2. So it is f of 2. So we plug in x equal to 2, it is 2 squared minus 4 times of 2 minus 6. We just clear for some space. And so we get 2 square is 4, and minus 4 times 2 is minus 8 minus 6. 4 minus 8 is minus 4 minus 6. So we get minus 4 minus 6 is minus 10. So I put minus 10 when x equal to 2. So from this table, we have to determine the minimum value as well as the maximum value of the function. Clearly, negative x is the maximum value and negative 10 is the minimum value. So therefore, we write absolute maximum x comma y as an ordered pair, and this equals 0 comma negative 6. This is absolute maximum, and absolute minimum as an ordered pair of x comma y, and this equals 2 comma negative 10. This is absolute minimum. So we have determined the absolute maximum and absolute minimum of the function. We now verify the absolute maximum and absolute minimum of the function by graphing the function using a graphing utility. So here we have the graph of the function f of x graphed using the graphing utility. This is defined for the interval 0 comma 2. Clearly we can see that 0 comma negative 6 is the absolute maximum. This is absolute maximum of the function, and 2 comma negative 10 is the absolute minimum of the function.